In this video, we are going to build important functions, sine and cosine. All right. We know that from previous video, I showed that cosine theta is our x, represented our x. Sine theta represent y. So this is cosine x, this is sine x. Okay, now let's write down also coordinates at this point. Our cosine x, or okay, let me put on theta because and x-axis and angle x, so it won't be confusing. I'll just put theta. Okay. So in this point, our the cosine is 1, sine is 0. So 1, 0. X is 1, y is 0. In this point, my x is 0, y is 1, which is cosine is 0, sine is 1. In this point, so it's going to be cosine, it's going to be negative 1. Oops. Y is going to be 0. And here, our cosine is going to be 0. Y going to be negative 1, which is sine, negative 1 here. Okay, and let me write down also angles in the radians. So here we have 0 radians. We have here 2 pi. Here we have pi over 2 radians. We have here pi. I guess blue wasn't the best idea, huh? Pi. Okay. Pi, here we got 3 over 2 pi. And here we got 2 pi. Okay, let's open this circle and see how it's gonna look like, this circle, if we lay down on x and y in the open way. This circle, it's like wire, it's circle and you open it up. And we are going to move this point on x and y. So, what do we have? Angles, important point. 0, half a pi, pi, 3 over 2 pi, and 2 pi. And because our circle is symmetric, so they are going to be away from each other on the same distance, obviously. And they are increasing by pi over 2. That's also witnessing equal the increase on equal distance. So it's going to be, let's say, this is going to be half a pi. 1, 2, 3, 1, 2, 3. This is going to be pi. 1, 2, 3. 3 over 2 pi. And 1, 2, 3, this is going to be your 2 pi. Okay, here we have x. Here we have y. So this is change of our axis. 0 degrees, half a pi, pi, 3 over 2 pi, 2 pi. Okay, now how is changing my y? Y can be maximum positive 1, negative 1, right? Minimum negative 1. So 1, 2, this is, let's say, positive 1. 1, 2, this is gonna be negative 1. Okay, now let's move points from the unit circle to our graph. At the point of 0 radian, how much is my sine? It's gonna be 0, right? So it's right here, this point. At the point of half a pi, my y is equal 1. Okay, so I provide dashes. This is 1. At the point of pi, my y is equal 0. So in the point, oops, half a pi. Okay, at the point of pi, it's gonna be 0. At the point of 3 over 2 pi, our y or sine x gonna be in the point of negative 1. And in the point of 2 pi, our y is gonna be 0, back to its own position, initial position. Trying to move a little bit so I can draw. Okay, so let's see. What I'm going to have here. So from 0, I'm heading to half a pi, where 1 is. Then I'm going to pi over 2, heading to 3 over 2 pi, coming here. This is what we got. This is how it looks like wave. Okay? Now, let's see, let's do observation on this graph. So from 0, from the point of 0 radian to half a pi, the graph is increasing. From the point of half a pi all the way to 3 over 2 pi, where pi is inflection point, its graph is decreasing. And from 3 over 2 pi, all the way to 2 pi, graph is increasing. Now, since our unit circle is 2 pi, so on the graph we also got from 0 to pi, and this 2 pi is going to be our period. What do we mean by that? That if I continue this graph, it will be, because it can have continuous, so it will go another possibly 2 pi or 3 pi or 4 pi or half a pi. So can it go to negative sign also? Yes, of course it can. So that's when you go counterclockwise and you will get your negative angles. So let me see, 1, 2, 3, this is going to be my negative pi. 1, 2, 3, this is going to be negative pi. So if I provide continuing line, so it's negative pi at the negative 1, it's going to be where negative half a pi is, which is right here, right? It's negative pi. So it's going to go from here to here. And then to the point of negative pi. See, if I go negative at the point of pi, negative pi, my sine is going to be 0 right here. Same thing. So I can continue here also, and so forth. So yes, we can continue, but the original unit circle, once we open, has period 2 pi. Now, this from a range, our range of y, that can fluctuate from -1 to +1. That's our range. We call amplitude. We call it amplitude. Let me move it here. Because our y is representing our sin x, sin theta, then we can say sin theta can change from -1 to +1. Same thing. Okay. What else here we can say is that entire graph is fitting from -1 to +1. This is -1 to 5. This is like channel fitting from -1 to +1, unless you change amplitude, like instead of sin theta you get 2 sin theta, or 1/3 sin theta, and so on. That's your amplitude coefficient. By default we have 1 amplitude, and it can change between -1, +1 for unit circle. Okay, we will discuss this much later. I'm just giving you some understanding. Next, let's build cosine theta. I'm going to build cosine theta. Okay, here we have 0, 1, 2, 3. This is pi over 2. 1, 2, 3, it's going to be pi. 1, 2, 3, 3 pi over 2, 270 degrees. And 1, 2, 3, we get to 2 pi. So let's explore cosine, see where we are heading with this cosine. Maybe I can move right under this unit circle so we can see. And this one also, the entire thing, move a little bit to the left so we can have space. All right. So let's explore cosine now. At the point of 0 radian, here it is, 0 radian, our cosine is going to be 1. So it's right here, it's going to be right here. Oops. And where is -1? It's going to be -1. So this is going to be 1. In the point of half a pi, our cosine is going to be 0, because here x is 0. Next, okay, in the point of pi, our cosine is going to be -1. In the point of 3 over 2 pi, our cosine is going to be 0. And in the point of 2 pi, our cosine is going to be 1. So let's see how it's going to go. Come from here. Down here. Goes through 0 and come here. This is our cosine. Okay? So pay attention. While sine start from 0, cosine start from 1. Okay? Now, what is interesting here? If I continue, obviously this is going to be -pi over 2. So our period for cosine, let's calculate. This is pi over 2, this is 3 pi over 2. So 3 pi over 2 minus pi over 2, it's going to be 2 pi over 2, which is pi. So this piece is going to be pi, right? This piece is half a pi, right? And this is also half a pi. So pi and 2 half a pi's, it's going to be 2 pi, period. Just like here. Two pi. Next, amplitude is also changing. So period is 2 pi. Amplitude is fluctuating from negative, for this unit circle obviously, greater equal -1, less equal 1, because for other circle instead of 1 we can have 5. So we will go through this. All right, which means y is also can change in the range -1 less equal +1, and we call amplitude. Now I want to compare cosine to sine. So let me see if I make a copy of this. Okay, and I want to move it here. No, I didn't make a copy. One more time. Okay, so all right, so I'm going to bring, well, I don't want it to be messy, so let me do some cleaning here. Let me move up here, clean this, and then I will move it. So let me clean real quick. Okay, not bad. Okay, I think it's good enough. All right, so now let me circle and put half a pi and pi, and I'm going to change the color on, okay, the thickest one. See, what can we say? So between them, between sin x and cosine x, there is a shifting by how much? 90 degrees, yes? Half a pi, 90 degrees. So which means if you take your sin x and shift to the left by half a pi, so this point will come to this point, so it will become cosine. So from here, I can say or write down that sin x plus half a pi, it's going to be equal cosine. Y plus, remember cosine is always, x is always changing in the opposite direction. If you do x minus 3, then you move towards positive 3. If you do x plus 3, then you move towards negative 3. That's from algebra, graphing and transformation of functions. I'm going to do such video also. So, and y is changing straightforward. If it's plus, you move to plus. If it's minus, you move to minus. X on the other side, if it's plus, you move towards negative. If it's negative, if it's minus, you move towards positive. So since we are moving to the left, right, towards negative more, then I put plus, so it will go left. So sine x plus, if I take sine x and shift by pi over 2 to the left, which means I am doing plus pi over 2, I will get cosine x. That's all. I will continue to explore sine and cosine. I will do transformation of these functions in my next video. Thank you for watching.